Solve the equation 2 cos theta equals 7 minus 3 over cos theta, for theta is an angle between minus 90 and 90 degrees. So the first thing we do is multiply every term by cos theta to remove the denominator. We have a restriction here. Cos theta cannot be 0. That means that theta cannot be 90 degrees or 270 degrees. So 2 cos squared theta equals 7 cos theta minus 3. All terms over to the one side. So we have a standard quadratic. You can use a substitution if you like, but it's not necessary. So cos theta equals a half, or cos theta equals 3. Cos theta equals 3 is not applicable. The largest possible value for cos theta is 1. The smallest possible value for cos theta is -1. The same thing incidentally applies for sin theta. So as soon as you see a value of sin theta or cos theta that is greater than 1 or less than -1, automatically that equation will be not applicable. The reference angle is 60 degrees. Our domain is theta is between minus 90 and 90. So we're in the first quadrant and the fourth quadrant. This is the positive. The first quadrant is the positive acute angle, and the fourth quadrant is the negative acute angle. So cos 60 is a half, and cos minus 60 is also a half. So the solution is theta equals minus 60 or 60 degrees. Question 2. The graph of y equals f of x is transformed to the graph of y equals f of 2x minus 3. Describe fully the two single transformations that have been combined to give the resulting transformation. Okay, so we have y equals f of x, and I'm going to call this one g of x. It's just nice to label functions. So what we are doing to f of x, if we just look at f of 2x, this is a horizontal stretch, a stretch that is parallel to the x-axis. So this over here is a. So recall that when you stretch horizontally, you have a multiplier a, and what that multiplier is, it indicates that your scale factor is 1 over a. So the fact that this a is 2, that means that the scale factor is a half. So the first transformation is a horizontal stretch scale factor of a half, and the second transformation deals with the minus 3 over here, which is a vertical shift. Of 3 units down the y-axis, or you could say it is a vector translation 0, minus 3. The point P56 lies on the transformed curve y equals f of 2x minus 3. State the coordinates of the corresponding point of the original curve y equals f of x. So the point 5,6 lies on this line. So 6 equals f of 2 times 5, f of 10 minus 3. So f of 10 is 9. This means that when x equals 10, y equals 9. So the point on the original curve is 10, 9. Question 3. The function f is defined as f of x equals x plus 3 over x minus 1 for x is greater than 1. Find the value of f of 5. Okay, before we do that, we need to find f of x. So f of x will be f of x plus 3 over x minus 1. So that will be for every instance of x, we are substituting with x plus 3 over x minus 1. So x plus 3 over x minus 1 plus 3 over x plus 3 over x minus 1 minus 1. So instead of manipulating this, we're just going to straight away substitute x equals 5. It's just going to be a lot easier. We can manipulate this, get a simplified expression involving x and then substitute, but because we've got fractions over fractions, it's going to be easier to straight away just sub in x equals 5. So f of 5 will be 5 plus 3 over 5 minus 1 plus 3 over 5 plus 3 over 5 minus 1 minus 1, just coming up here. We'll have that equals 8 over 4 plus 3 over 8 over 4 minus 1. 2 plus 3 is 5. 2 minus 1 is 1, so it'll just be 5. Find an expression for the inverse of f. Okay, so f of x equals x plus 3 over x minus 1. So the inverse of f would be x equals y plus 3 over y minus 1. And now we make y the subject. Xy minus x equals y plus 3. Take out a common y, and y equals x plus 3 over x minus 1. So f to the minus 1 of x is x plus 3 over x minus 1. And we get exactly the same function as f. And this sometimes happens with hyperbole. So don't be alarmed if you do come across this. Sometimes hyperbola is an inverse of itself. Question 4. A curve is such that dy dx equals 8 over 3x plus 2 all squared. The curve passes through the point 2, 5 and 2/3. Find the equation of the curve. So we are given the gradient function of a curve. And we're required to find the equation of the curve. So we're going to be integrating the gradient function. So y equals 8 is a constant, so we can just pull that out of the integration. That'll be 1 over 3x plus 2 all squared, which we're going to write as 3x plus 2 to the minus 2 dx. Now we can integrate. 3x plus 2 to the minus 2 will be 3x plus 2 to the minus 1 divided by minus 1. We also multiply by 1 over the derivative of 3x plus 2. So we multiply by a third, and then we add the constant of integration. So y equals, we'll have minus 8/3 times, we're just going to write this in a better form as 1 over 3x plus 2 plus c. This is the equation of the curve. We now need to find the value of the constant of integration. So we're going to substitute the point that lies on the curve. 17 over 3 equals minus 8 over 3 times 1 over 3 times 2 is 6. 6 plus 2 is 8 plus c. 17 over 3 equals minus a third plus c. c equals 18 over 3, which is 6. So the curve is y equals minus 8 over 3 times 3x plus 2 plus 6. Question 5. The first, third, and fifth terms of an arithmetic progression are 2 cos x, minus 6 root 3 sin x, and 10 cos x, respectively, where x is an angle between pi by 2 and pi. We're required to find the exact value of x. Okay, the exact value, meaning we are not working with decimals, right? We're working in terms of surds or pi. So the first term is 2 cos x. So we have an arithmetic series. The first term is 2 cos x. The third term is minus 6 root 3 sin x. The third term of an arithmetic sequence is a plus 2d. And the fifth term is 10 cos x. So a plus 4d equals 10 cos x. Okay, so now we're just going to substitute and manipulate. A is 2 cos x. So 2 cos x plus 2d equals minus 6 root 3 sine x. We can divide through by 2. So we'll have cos x plus d equals minus 3 root 3 sine x, and then d is minus 3 root 3 sine x minus cos x. We can now substitute a and d into this expression. 2 cos x plus 4 times minus 3 root 3 sine x minus cos x equals 10 cos x. Minus 12 root 3 sine x equals 10 cos x plus 4 minus 2. That'll be 12 cos x. We can divide through by 12. Minus root 3 sine x equals cos x, and dividing through by cos give us minus root 3 tan x equals 1. Therefore tan x equals minus 1 over root 3. The minus sign here just means that the solution lies in a quadrant where the ratio tan is negative. So to find the reference angle, we just take the positive acute angle 1 over root 3, shift tan, and remember we're working in radians here. So let's first work in degrees. Shift tan 1 over root 3 means that x will be 30 degrees, and in radians that will be pi by 6. So the reference angle is pi by 6. The negative means the solution lies in a quadrant where tan is negative. So taking the restriction, the domain, into consideration, between x is an angle between pi by 2 and pi, so that's pi by 2 and that is pi, so we're working in the second quadrant. Tan is clearly negative in the second quadrant, so the only solution will be in the second quadrant. So reference angle is pi by 6, which means the solution x is pi minus pi by 6, x equals 5 pi by 6. Hence find the exact sum of the first 25 terms of the progression. Okay, so n equals 25. A is 2 cos x. Remember that x is 5 pi by 6. So A is 2 cos 5 pi by 6. A is minus root 3. D is minus 3 root 3 sine x minus cos x. X is 5 pi by 6, so it's minus, d is minus 3 root 3 sine 5 pi by 6 minus cos 5 pi by 6. D is minus root 3. So d is minus root 3, a is minus root 3, and n equals 25. So sum to n terms of an arithmetic sequence is n over 2 times 2a plus d times n minus 1. The sum to 25 terms is 25 over 2. 2 times minus root 3 minus 2 root 3. D is minus root 3. N minus 1, 25 minus 1, 24. That's 25 over 2. Minus 24 root 3 minus 2 root 3 is minus 26 root 3. So the sum to 25 terms equals minus 325 root 3. They wanted the exact sum, so no decimals. This is how you leave your answer. Question 6. The second term of a geometric progression is 54, and the sum to infinity of the progression is 243. Common ratio is greater than a half. We're required to find the 10th term, leaving the answer in exact form. So the second term is 54, which means that AR equals 54. The sum to infinity is 243, so A over 1 minus R equals 243. We can just isolate A here and isolate A here, and then put these two expressions equal to each other. R multiplying through by R, 54 is 243 R minus 243 R squared. Get this into standard quadratic form. 9R squared minus 9R plus 2 equals 0. So R equals a third, or R equals 2/3. Now they did say that the common ratio is greater than a half, so a third is not applicable. R equals 2/3. 10th term of a GS is given by AR to the 9. We need to find A first. So A is 54 over R, which is 54 over 2/3. So A is 81. So the 10th term equals 81 times 2/3 to the power of 9, which equals 512 over 243. Question 7. In the diagram, the lengths of AB and AC are both 15 centimeters. Point P is the foot of the perpendicular from C to AB. The length CP is 9 centimeters. An arc of a circle with center B passes through C and meets AB at Q. Show that the angle ABC is 1.25 radians. Correct to 3 significant figures. Okay, angle ABC, let's just, for simplicity's sake, we'll just call that theta. So we need to show that theta is 1.25 radians. We have an isosceles triangle, ABC, because AB equals AC, which is 15 centimeters. So angle ACB is therefore also theta. Angle BAC, if we call this alpha, then alpha plus 2 theta equals pi radians, interior angles of a triangle. Now the reason we're referring to alpha is because triangle APC is right angled, which means that Pythagoras' theorem and trig ratios apply. So we have the length of PC, which is 9. We have the length of AC, which is 15. So relative to alpha, PC is opposite and AC is the hypotenuse. So opposite of hypotenuse is sine alpha. So sine alpha equals 9 over 15. Therefore, alpha equals 0.6435 radians. We can now work out theta. So 0.6435 plus 2 theta equals pi. 2 theta is pi minus 0.6435. Theta is therefore pi minus 0.6435 divided by 2. 1.2490 radians, which approximates to 1.25 radians. Or at least the sector BQC comprises the shaded region and triangle, right angled triangle BPC. So to find the area of the shaded region, we're going to first find the area of the sector BQC. and then subtract the area of triangle BPC, and that'll give us the area of the shaded region. So the area of the shaded region is the area of sector BQC minus the area of triangle BPC. So the area of the shaded region equals the area of the sector BQC. The area of sector BQC is a half the radius squared. So the radius of sector BQC is BQ and BC. So half BC squared times the sector angle of 1.25 minus the area of the right angle triangle BPC is a half base times height. So half BP times PC. BC we can determine in the right angle triangle because it's the hypotenuse of the triangle relative to the angle 1.25 radians. 9 is the opposite side, 9 centimeters PC, and BC is the hypotenuse. So opposite of hypotenuse equals sine 1.25. So sine 1.25 equals 9 over BC. So BC equals 9 over sine 1.25, which is 9.48. We're just going to round that up to 9.5 centimeters. So we've got BC. Now BP, we can do this a similar thing. Relative to 1.25 in right angle triangle BPC, BP is the adjacent side and PC is the opposite side. So 9 over BP is opposite over adjacent, so that's going to be tan 1.25. BP therefore equals 9 divided by tan 1.25. It's 2.99, so it's approximately 3. So we've got BP and we've got BC. So the area of the sector, the area of the shaded region, equals a half times BC squared. So it's going to be 9.5 squared times 1.25 minus a half. BP is 3 and PC is 9. So the area of the shaded region therefore equals approximately 42.91 centimeters squared. Question 8. It's given that in the expansion of 4 plus 2x times 2 minus ax to the power of 5, the coefficient of x squared is minus 15. Find the possible values of a. Okay, so we're just going to expand the second binomial first. So 2 minus ax to the power of 5 is 5 choose 0 times 2 to the 5 plus 5 choose 1 times 2 to the 4 times minus ax plus 5 choose 2 times 2 to the 3 times minus ax squared plus 5 choose 3 times 2 squared times minus ax to the 3 plus 5 choose 4 times 2 to the 1 times minus ax to the 4 plus 5 choose 5 times minus ax to the 5. Now, when we consider, we're going to be multiplying each of these terms here by 4 plus 2x. And from that product, we are looking for terms that contain x squared because we need the coefficient of the x squared terms. So we're just going to consider terms here that will give us terms in x squared. So this term here, 4, will be multiplied by a term in x squared, which means this term is what we need, one of the terms that we need. This term over here, 2x, will be multiplied by a term of this expansion such that we get an x squared, and the term that's going to give us that will be this term here. So term 2 and term 3 of this expansion will give us what we're looking for. All the other terms will not give us a term in x squared. 4 times this term will not give us a term in x squared. 2x times this term will not give us a term in x squared, so we can discard that term. This term over here contains a term in x cubed. When we multiply it by 4 or by x, we're not going to get a term in x squared, so that is also discarded, as is that term and that term. So we're just going to consider, going to put an ellipsis there, just to indicate the terms that precede the terms we're going to write down. So 5 choose 1. We'll just expand this. That's going to be 2 to the 4 is 16 times minus ax plus 5 choose 2. 2 cubed is 8. And then minus ax all squared is going to be a squared, x squared. And then we have the terms that come after that. So we're now looking for terms that are going to give us terms in x squared. So we're going to look at this term and that term. So we will have 2 times 5 choose 1 is 5 times 16 times x times minus ax is minus ax squared. And then this term 4 times that term will also give us a term in x squared. So we're going to add 4 times 5 choose 2 is 10 times 8 a squared x squared. So just multiplying this all out, we have minus 80 times 2 is minus 160 ax squared plus 320 a squared x squared. Now what we're interested in is the coefficient of x squared. So the coefficient of x squared is minus 160a plus 320 a squared. So minus 160a plus 320a squared equals minus 15. So 320a squared minus 160a plus 15 equals 0. 64a squared minus 32a plus 3 equals 0. So a equals 1 over 8, or a equals 3 over 8. It's given instead that in the expansion 4 plus 2x times 2 minus ax to the power of 5, the coefficient of x squared is k. It's also given there's only one value of a which leads to this value of k. Find the values of k and a. Okay, so the coefficient of x squared in this expansion was 160a plus 320a squared. They're now saying that the coefficient of x squared is k. So we have basically the same quadratic, it's just that we now have a constant k to consider. So we still write this in standard quadratic form, and we now determine an expression for the discriminant b squared minus 4ac. So that'll be minus 160 squared minus 4 times 320 times minus k, delta equals 25600 plus 1280 k. Now they say that there's only one value of a which leads to this value of k. So they're talking about equal roots. In other words, delta equals 0. So 25600 plus 1280 k equals 0. Therefore, k equals minus 20. So therefore, 320a squared minus 160a equals minus 20. 320a squared minus 160a plus 20 equals 0. Divide through by 20. 16a squared minus 8a plus 1 equals 0. A equals a quarter, or A equals a quarter. This just confirms that there's only one value of A, which is a quarter, which leads to this value of K. So A is a quarter, K is minus 20. We write down both values of A. There's only one value of A, but we write them down both because we are dealing with a quadratic. Question 9. The volume V cubic meters of a large circular mound of iron ore or radius r meters is modeled by the equation V equals 3 over 2 times r minus a half to the power of 3 minus 1 for r is greater than or equal to 2. Iron ore is added to the mound at a constant rate of 1.5 cubic meters per second. Find the rate at which the radius of the mound is increasing at the instant when the radius is 5.5 meters. Okay, we are required to find the rate at which the radius of the mound is increasing. Increasing implies change, positive change. The radius is changing at a rate. So the differential that we are dealing with is dr dt. And we are required to find this differential. So this is what we're required to find. We'll deal with this when we need to. We need to find the value of this differential at a time when the radius is 5.5 meters. So we first need to find an expression before we can use this. The volume V is given by V equals 3 over 2 times r minus a half cubed. From this we can get the differential dV dr. And we're also told that iron ore is added to the mound at a constant rate of 1.5 cubic meters per second. So cubic meters per second, volume per second, this is the differential dV dt, and that equals 1.5. We now need to relate these three differentials by establishing an equation. So dr dt equals dr dV times dV dt. So the first thing we're going to do now is find an expression for dV dr. So differentiating this expression, 3 over 2 times 3 will be 9 over 2 times r minus a half to the 3 minus 1 to the power of 2 times the derivative of r minus a half, which is just multiplying by 1. So dV dr is 9 over 2 times r minus a half squared. So dr dV is just going to be the reciprocal of this expression, 9 over 2 times r minus a half squared, 2 over 9 times r minus a half squared, then times dV dt, which is 1.5. Now we need to determine the value of dr dt when when the radius is 5.5 meters. So dr dt when r equals 5.5 equals 2 over 9 times 5.5 minus 0.5 squared times 3 over 2. So it's going to be a third times 1 over 5 squared, which is 25, which is 1 over 75. Find the volume of the mound at the instant when the radius is increasing at 0.1 meters per second. Okay, so now they are giving us, or they're telling us, that the radius is increasing at that rate. So the radius is changing positively at a rate dr dt equals 0.1 meters per second. We need to find the volume at this instant when the radius is increasing at that rate. So the volume is 3 over 2 times r minus a half cubed minus 1. We're given dr dt 0.1. We have the differential dv dr. We now just need to find the volume when the radius is increasing at 0.1 meters per second. dv dt is 1.5. So dv dr equals dv dt times dt dr. dv dt is 1.5 and dt dr is the reciprocal of 0.1, so it's 1 divided by 0.1, which equals 15. So this expression dv dr equals 15. 15 now we just solve for r minus a half all squared equals 30 over 9. R minus a half equals plus or minus the square root of 30 over 9. R is a half plus minus the square root of 30 over 9. So R equals 2.326 meters. We obviously invalidate the negative solution because we are dealing with a radius. So R equals 2.326 meters at a time when the radius is increasing at 0.1 meters per second. So the volume when R equals 2.326 will be 3 over 2 times 2.326 minus 0.5 cubed minus 1, which equals 8.133 cubic meters. Question 10. The function f is defined by f of x equals x squared plus k over x plus 2 for x is greater than 0. Given the curve with equation y equals f of x has a stationary point when x equals 2, find k. Okay, we have a stationary point where x equals 2, and we have a function, a curve f of x. To find stationary points, we differentiate the function and equate it to 0. So the stationary points f prime x equals 0. Before we do that, we need to put f of x into differentiable ready form. So k squared plus kx to the minus 1 plus 2. F prime x equals 2x minus k x to the minus 2, which is 2x minus k over x squared. So 2x minus k over x squared equals 0. We have a stationary point when x equals 2, so 2 times 2 will be 4 minus k over 2 squared, 4 equals 0. 16 minus k equals 0, therefore k equals 16. To determine the nature of the stationary point, we need to find the second derivative. The first derivative is 2x minus k over x squared, and we know k is 16, so it's 2x minus 16 over x squared. The stationary point occurs when x equals 2. So the second derivative, let's just put the first derivative into differentiable ready form, 2x minus 16x to the minus 2. So f double prime x, the second derivative, equals 2 plus 32x to the minus 3, which is 2 plus 32 over x cubed. And we need to know what the nature of the stationary point is. And the stationary point occurs where x equals 2. So f double prime 2 equals 2 plus 32 over 2 cubed is 8. 2 plus 4, which is 6. The calculation doesn't matter because we can see it's positive. It's clearly greater than 0. Therefore, we have a minimum stationary point where x equals 2. Given that this is the only stationary point of the curve, find the range of f. Okay, well, f of x equals x squared plus 16 over x plus 2. And we have a stationary point where x equals 2, so f of 2 equals 2 squared plus 16 over 2 plus 2. That's 4 plus 8 plus 2, which is 14. So the range of f will be f of x is greater than or equal to 14. Question 11. The diagram shows the line x equals 5 over 2. Part of the curve y equals half x plus 7 over 10 minus 1 over x minus 2 to the third, and the normal to the curve at the point A, 3, 6 over 5. We're required to find the x-coordinate of the point where the normal to the curve meets the x-axis. So we need to find the equation of the normal. So the normal to the curve passes through the point A. So to find the equation of a normal, which is a straight line, we need to know the gradient of the line and one point that lies on the line. We've got that point. That point is A. We just need to find the gradient of the normal. To find the gradient of the normal, we're first going to find the gradient of the tangent to the curve at A. A normal and a tangent are perpendicular to each other, so the gradient of the tangent times the gradient of the normal is -1. That's the criteria for perpendicular lines. So to find the gradient of the tangent, to find the gradient of the normal, we're first going to find the gradient of the tangent, and then take the negative reciprocal of the gradient of the tangent, and that'll give us the gradient of the normal. To find the gradient of the tangent, we are going to differentiate the curve. So dy dx equals a half. The derivative of the constant is 0. So we have a half minus, becomes a plus because we're multiplying by minus a third. It's going to be a third times x minus 2 to the minus a third minus 1 to the minus 4/3 times the derivative of x minus 2, so just multiplying by 1. So dy dx is a half plus 1 over 3 times x minus 2 to the 4/3. Dy dx, this expression here represents the gradient of the tangent of a tangent to the curve. Specifically, the tangent at A occurs when x equals 3. So dy dx when x equals 3 is a half plus 1 over 3 times 3 minus 2 is 1. 1 to the 4 over 3 is still 1. So a half plus a third, which is 5 over 6. 5 over 6 is the gradient of the tangent to the curve at point A. So we've got the gradient of the tangent now. So the gradient of the normal is the negative reciprocal of 5 over 6. So the gradient of the normal is minus 6 over 5. We have the gradient of the normal. We have the point A, 3, 6 over 5. The point through which the normal passes through the curve. So we can now determine the equation of the normal. So y minus y1 equals m times x minus x1. Of course, you can also use y equals mx plus c if you wish. It's just quicker to use this equation to find the equation of a straight line. So y minus 6 over 5 equals minus 6 over 5 times x minus 3 So y equals minus 6/5 x plus 24 over 5. And this is the equation of the normal to the curve. Now we're required to find a point where the normal cuts the x-axis. So we are looking for the x-intercept of the normal. So the x-intercept happens when y equals 0. So 0 equals minus 6/5 x plus 24 over 5. Multiply through by 5. 0 equals minus 6x plus 24. 6x equals 24. X equals 4. So the x-intercept is 4, 0. Find the area of the shaded region, giving your answer correct to 2 decimal places. So the area of the shaded region. Now we need to consider the fact that we are not dealing with a single function, a single continuous function, I should say. We have a curve, then we have a straight line, which we also call a curve, right? We've got two curves here. And it's not continuous, right? We have at point A, we have what is called a discontinuity. This function, the curve itself, the blue curve, is continuous, but when you consider the fact that we're dealing with the shaded region here, at point A, there's a discontinuity because we have a different function, right? It's not a continuous function. So we have what's called a discontinuity at A. So what we have to do is we have to drop a perpendicular to the x-axis and divide the shaded region into two separate regions. So we'll have area 1 and area 2. So we can consider each area individually. The first area, the boundaries of integration will be from this point, 5 over 2, to the x value at A, which is 3. So area 1, we are going to be integrating between x equals 5 over 2 and x equals 3 of this function here. So let's just call that f of x. And area 2, we will be integrating from x equals 3 to this point over here. That's why we were required in the first part of this question to find the x-intercept of the normal. That green line represents the normal through A. So this point was 4. So area 2 will be integrating between x equals 3 and x equals 4, and the normal we'll just call g of x. Determine area 1 and area 2, and then sum the two to get the area of the shaded region. Area 1 equals the integral of a half x is going to be a half x squared times a half plus 7 over 10x minus x minus 2 to the minus third plus 1 to the 2/3 divided by 2/3. We're multiplying by 3 over 2, and we multiply by the derivative of x minus 2, so we multiply by 1, which you don't have to write in. And this is evaluated between x equals 5 over 2 and 3. It's area 1 equals, so area 1 is 0.483 units squared. The area of the shaded region therefore equals 0.483 plus 3/5, which is 0.6. That equals 1.083 units squared. Question 12. The diagram shows a circle with the equation x squared plus y squared minus 6x plus 4y minus 27 equals 0, and the tangent to the circle at P, 5, 4. The tangent to the circle at P meets the x-axis at A and the y-axis at B. Find the area of triangle OAB where O is the origin. Okay, so to find the area of the triangle OAB, we're going to need to know the length of OB and the length of OA, since they represent the base and the height of that right angle triangle. So to find the length of OB and the length of OA, we need to know the coordinates of A and B. To find the coordinates of A and B, we're going to need to know the equation of line BPA, which is the tangent. So essentially they're asking us to find the equation of the tangent. So to find the equation of a tangent, which is a straight line, the general equation of a straight line is y equals mx plus c. We need to know the gradient of the line, so we need to know the gradient of the tangent, and we need to know one point that lies on the line. The point that lies on the line, since we're required to find points B and A, we have to use point P, which we know. They gave us the point P, which is 5, 4. So we have the point. We know the point. We just need to find the gradient of tangent BPA now. So to find the gradient of the tangent, we are given a circle with a center, which is not indicated, but we can indicate the center. Let's say the center is around about there. We know that the radius, MP, will be a radius, and that radius is perpendicular to the tangent at the point of contact. So we can find the gradient of this tangent by finding the gradient of the radius MP. So we know the coordinates of P, 5, 4. If we can find the coordinates of the center M, we can then determine the gradient of MP, and from that we can then find the gradient of the tangent. From that we can determine the equation of the tangent, and then we can find the coordinates of A and B, and hence find the area of the triangle. So it's quite a process, but let's take it step by step. Okay, so the first thing we're going to do is find the coordinates of M. So x squared minus 6x plus a bracket squared plus y squared plus 4y plus a bracket squared equals 27 plus bracket squared plus bracket squared. Okay, in the first bracket, half the coefficient of x, half of minus 6 is minus 3. And in the second bracket, half of 4 is 2. This will give us x minus 3 all squared plus y plus 2 all squared. And that'll be 27 plus 9 plus 4. So this is the equation of the circle, the center of which is 3 minus 2. So these are the coordinates of M. P is the point 5, 4. We can now determine the gradient of MP, which is y2 minus y1 over x2 minus x1. So 4 minus minus 2 over 5 minus 3. There'll be 6 over 2, which is 3. The gradient of MP equals 3. Therefore, the gradient of the tangent will be the negative reciprocal of that, which is minus a third. So y minus y1 equals m times x minus x1. Y minus 4 equals minus a third times x minus 5. Y equals minus a third x plus 5 thirds plus 4. Y is minus a third x plus 17 over 3. If you like, you can write this as 3y equals minus x plus 17. And this is the equation of the tangent to the circle at P. We're not done yet because we're required to find the area of triangle OAB. So to find the coordinates of A and B, A the x-intercept, B the y-intercept, we put y equal to 0 and x equal to 0. So the x-intercept will be when y equals 0, so 0 equals minus x plus 17. X equals 17, so A is the point 17, 0. the y-intercept when x equals 0, so 3y equals 17, y 17 over 3. So b is the point 0, 17 over 3. Now finally we can find the area of the triangle OAB. So area triangle AOB is half base times height, so half 17 times 17 over 3, and that will be 289 over 6 units squared. Points Q and R also lie on a circle such that PQR is an equilateral triangle. Find the exact area of triangle PQR. So being an equilateral triangle, each of the interior angles are 60 degrees. If we join MP, MQ, and MR, each of those line segments are radii of the circle. The reason we do that is we are going to use the sine rule for each of these triangles here and add them up, and they'll give us the area of triangle PQR. We know that the radius of the circle is root 40 because r squared is 40, and each of these MP, MR, and MQ is the radius of the circle, which is root 40. So if we have area 1, area 2, area 3, these will all be equal. So we just have to find one of the areas and then multiply by 3. So the area of triangle PMR is, using the sine rule, a half r squared sine 120 degrees. So the area will be a half r squared, so it's going to be half root 40 squared sine 120. So it's a half times 40 sine 120 is root 3 over 2. It's going to be 10 root 3. So the area of triangle PQR is going to be 3 times 10 root 3, because we have 3 identical triangles there, which is 30 root 3 units squared.